Okay, welcome. Welcome to the beginnings of differential equations. It's as if we're going back in time and what were they struggling with and how did they develop it and stuff. This particular exercise is it's actually new to me from this textbook, and it's really quick. It's not too painful. It has you read Theorem 1 in your textbook. All these problems are coming from the e-text, and the theorem is talking about existence and uniqueness of solutions. Mathematicians have to find these things out, man. You think you solved it. Does it actually exist? Is the domain like no numbers or at all? Or does it, what's the story? Really a matter of exploration, if you will, in this case. So the theorem to determine if the existence of at least one solution exists and if it's unique, actually I chose number 16, forgot to write it down. So what it is dy dx is equal to the square root of, notice, x minus y. So I can't do the integration trick from the previous section because it's got a y in it, not just x. And then it has an initial condition, y of 2 is equal to 1. Well, the theorem says one thing: existence. Okay, so they use this notation. Let me write it somewhere. Right here, I guess you could say. If you call this f of x comma y, that'll warm the cockles of the hearts of people that went through Calc 3. Yes, multivariable. It is. The derivative is actually a function of x and y, two variables, but don't get hung up on that. So the existence part of the theorem says is f of x, y, which is really dy dx, which is really in our problem, the square root of x minus y. Is it continuous at the point 2 comma 1? Okay, so it gets kind of ticky-tacky. That's math, man. You want to prove this down. It's either pure math or it goes into applied math, and you go, well, according to the recipe, dy dx is continuous at 2, 1, then we're good. So look at dy dx, explore that guy, and you go, okay, this is my guy. So what's the story on him? Well, this guy is continuous because it's the square root function, which is continuous, but it is only defined, right, when what do you call that thing? I forget, radicand, okay? The radicand, if x minus y is greater than or equal to 0. Because I'm not going to square root a negative and get into complex numbers. That's a whole different world. But what that really tells us is as long as x is greater than or equal to y, look, over here, you see it? And 2, x equals 2 is greater than 1, which is y, we're good. So part 1 is done. There exists at least one solution at the point 2 comma 1. So that's theorem. Okay, hey, I'm not proving that theorem. We're just going to use it. You want to see that proven? You do upper division mathematics and go into those courses, and it's wonderful stuff. Take it from me. Okay, but then there's another part to this. There's uniqueness. Now, I just read it from the book, and I go, well, that's interesting. What they do is they go, is f sub y of xy continuous at 2, 1? Okay, Calc 3 graduates, what's f sub y all about? That is the partial derivative with respect to y. So those of you that have not had Calc 3, don't despair. What you do is you derive f of xy, treating x as a constant. and y is the live variable. Just for you guys, I write that out, and that's all you have to do. So what is f? Well, you're talking about dy dx, and that's equal to f of xy, and that's equal to the square root of x minus y. And what we're going to do is we're going to go f sub y of xy is going to be the derivative of that function, okay, with respect to y. With respect to y. So when you do it, you go, oh, it's a square root. The outer, it's a chain rule. This is a chain rule. The outer function is the square root. Do you remember that it goes 1 over twice the square root of whatever? And you'd like to be done, but you're not, because now you got to derive, and look, I'll use this notation, the partial derivative with respect to y of x minus y. So you treat x as a constant, okay? And what we're going to get is we're going to get 1 over twice square root x minus y times, well, the derivative of a constant is 0. The derivative of y, as if it were it is the live variable, all you get is a -1. So f sub y is equal to a -1 over 2 square root of x minus y. And all we really want for this exercise is to know, is it continuous at 2, 1? Okay, well, this thing is continuous everywhere, except, let's put this in red, except you got to worry about this guy. This time, x minus y has got to be strictly greater than 0, because if it is 0, you're dividing by 0, that's an issue. So, in fact, I was playing around with this a little bit, and the actual area where you're good is here, not even on the line. This is the line y is equal to x. Don't worry about that. It's me just gathering some intuition. And 2, 1 is actually on this side where things are cool, because x is greater than y. Well, 2, again, is greater than 1. And so this implies unique. There exists a unique solution. What? a unique solution at that point. At the point 2, 1. Now, no one said what the solution was, what the function is that goes through that point, but this theorem is really cool to be able to say, I know it exists. Now, let's go find the thing, okay? And that's it. Now, the next video I'll introduce right now, I'll just say, then you're still in the archaic ages. We're going to look at direction fields, and I'll show you how to do that as well. All right, you having fun studying, right? Me too.